Hey everyone, in this video we'll see that how we can implement queue using linked list. Let's start. Implementations of queue using linked list is very easy. We just have to take care of few parameters. Whenever we are trying to implement queue using linked list, we have to follow some parameters. So let's say that we have a queue and we have a pointer like head, or you can say that we have a pointer like queue. So if our head is null or our queue pointer is null, it means we don't have any value within our queue. It means our queue is underflow. For performing the enqueue operation, we'll add the data at the end of the list, and for performing the dequeue operation, we'll delete the data from the beginning. Enqueue operation will take order of n and dequeue operation will take order of 1. So this is how we can implement queue using linked list. I have already discussed about that how you can add any node at the end of a linked list. If you don't know that how we can add any element at the end of the list, just click on the I button and watch this video. And another thing is, for dequeue we have to delete the data from the first. If you don't know how to delete any element from the beginning of a list, just click on the I button and watch that video. But in this video I'll talk about that how you can perform enqueue and dequeue using list. For performing the enqueue operation, at first we have to create a node, then we have to take the data from the user, then we have to set the next as null. Then if our queue is null, it means we don't have any data within our list or within our queue. You just set queue as temp. If you have more than one value within your queue, you just make a while loop, go up to null and add the data within your list. In my insertion at the end of a list video, I have discussed about these things in more detail. If you don't know that how to do that, just click on the I button and watch this video at first. This is how we can perform the enqueue operation in queue. So let's say that we have two data and we want to enter other data, or we want to perform enqueue operation again. So what we have to do, we have to check that at first our queue pointer is null or not. Our queue pointer is not null, then we'll take a reference pointer, then we'll go up to null and we'll access the elements until ref next not equals to null. We all know that the next address of the last node will be null, so we'll just add the newly created node here, let's say 100. So this is how we can add any element at the end of the list. And now we'll talk about the dequeue operation. For performing the dequeue operation, we have to delete the element from the first position. If you don't know that how to delete the element, just click on the I button and at first see this video that how we can delete any data from the beginning of a list. So for deleting the data, we'll take a reference pointer. At first we'll check that how many data we have within our queue. Let's say that we have only one data within our queue. We'll just set this data into del and we'll just make our head equals to null. So we'll just set queue equals to null. Else what we'll do, we'll just set queue into del and we'll just move our queue to queue next. It means, let's say that we have three nodes within our list. Now what we'll do, we'll just set this data into del and we'll just move our queue to queue next. So now queue pointer or head pointer will be pointing to this node. Then what we'll do, we'll just free this memory. So this is how we can delete any element from the beginning of a list. I think these portions are clear. If you have any doubt, just write in the comment section. Now we'll dive into code. So as you can see in my screen, we have declared a node, we have one data and we have one address part. Our head is null. You can replace this head with queue as well. So let me replace this head with queue. Let me replace head with queue. So I have replaced all the head with queue. This function is for allocating memory and this is the enqueue function. This function will make sure that we'll add the data at the end of the list. And this function is only for your reference, that we'll see that how many data we have within a list or within our queue. And you can see that there is a dequeue function. You can see if our queue is null, we'll just say that queue is empty or underflow. And if we have only one value within our queue, we'll just make our queue as null and we'll just set our first node into del. And then at last we'll delete the data. And if we have more than one value within our list, we'll just set that into del and we'll just move our queue pointer. As you can see that we have added 3 data and we are dequeuing 4 times. So here we'll get that our queue is empty. So let me compile the code. So at first we'll put some data, let's say 10, data added into the queue, 20, 30. So we have added 3 data. At first we have deleted 10, then we have deleted 20, and at last we have dequeued 30. And here we are getting that queue is empty. So you can see that we have successfully added 3 elements within our queue and we have deleted 3 elements. Now you can ask me one thing, this queue has no limit because we are using linked list. Linked list is infinitely finite. If you don't know why linked list is called infinitely finite, just click on the I button and watch the video. But if you want to put the size limit, then just take a counter and put whatever size you want. In this video we have discussed that how we can implement queue using linked list. If you have any doubt, just write in the comment section. See you in the next video.